Hey Felix, so welcome to the first edition of the AI Plumbers conference. How do you find it?
So far, so good. It's nerds talking to nerds about nerdy stuff. It's great.
Exactly, and that's actually why I kind of thought about, with a group of people that, we all put it together, that we need a conference like that. Because I went to tons of AI conferences in the past 2 years, and it's always, at least in the United States, about some marketing messages being pushed and AGI and this and that. I want to talk to my peeps. I want to talk to people like you, like the compiler engineer people, the people who know their IR from, their AGI, right? And I think this is exactly the conference for this. So your background is in compilers, right?
No, assembly nerds.
Oh.
So my kind of big start in the world was working on OpenBLOS. So I'm a huge Formula One nerd. That led me to how do you simulate the cars every weekend? And then from there, that led to how can I drive the performance in that? Mm-hmm. And that led me down the path. I'd already submitted patches to FFmpeg, performance work. Yeah. So assembly was kind of right there. And then how do I drive performance? And the new field of research at the time was mixed and reduced precision, which if you know where we are with AI these days, it's how do I increase my quality of output while reducing my precision? It's a whole quantization discussion and so on. But when you look at software to implement that, that's a non-trivial task. So how you attack it, how you drive performance at it while still getting quality results has been hugely interesting in the last few years. And that's where my focus was.
This is amazing because, again, I think this is the message we need to get out, far and wide, that finally people like you and I, we actually have a real, job ahead of us in this whole AI space, right?
Yeah.
Because I used to talk to my friends, again, my background is in compilers. I used to do compilers for some microsystems, for Spark. And then I did, FFmpeg a little bit on the open source side. And all of my buddies, we've been talking about this AI, ever since ChatGPT came out. And all of them are well, not ML engineers, we're not AI researchers. What are we going to do with all of this, right? It's our knowledge is kind of useless. I mean, NVIDIA gives everybody CUDA, we're done. It's all done. But all of a sudden, the whole industry is got shook up, and it's fashionable again. You can do chips, like what Tenstorrent is doing. You can do compilers again, and people are actually arguing what compiler intermediate representation is better than the other one. And I think open source has such a significant, huge role to play in all of this. So we absolutely do need a conference where people come together and figure out the building blocks for these types of solutions. And you guys at Tenstorrent, you rely a lot on the open source building blocks.
All the way through. All of our compilers, fully open source. And then when we build the hardware, we designed around the RISC-V ISA. So RISC-V is a fully open spec. Anyone can implement it, which means there's also a lot more pressure on us, right? Like open source, when you build something, is you want to be the best because everyone can go and look underneath and say, this is good, this is bad, right? So we build RISC-V, and then the pressure on us is we have to build the best RISC-V processor, we have to build the best open accelerator. And one of the things that does is it keeps the pressure on us, but it also empowers the user, where the user knows that, hey, I'm not locked in here, so it's worth investing in the ecosystem and spending time with it and learning it, because maybe it's Tenstorrent today or tomorrow, but it means that if Tenstorrent stops delivering, they can go somewhere else. So that's great for me because it keeps a fire under me to go and deliver and build incredible products and work with the community. That's really important to us.
That's absolutely right. And I think, one of the really interesting points in all of this is, again, because the industry has been driven by vendors for so long, people don't even realize that now is the time for us to get together and hash out some of those issues. Again, the name of the conference is, play on the Linux Plumbers conference. And, I was in that movement way before, my first patch in Linux, I think, landed in 96. And the AI Plumbers conference basically takes onto that same message of saying there needs to be a place for all of us to come together and think through end-to-end problems. Because Linux Plumbers conference was put together by people who said, look, we need Chromebook type of laptops to boot in a given number of seconds. That is the use case. What needs to happen? We cannot go to just Linux kernel conference because that's just part of the puzzle. We cannot just go to the firmware conference. That's just part of the puzzle. Where's the place where you can basically think through all of those end-to-end issues? And that's, again, the rest is history. So we really hope that the AI Plumbers conference is going to follow in the same footsteps. But to not, rattle off for too long, I actually have a few questions for you. Just to get to know you and for the rest of the people. Yeah, exactly. Let's get to the fun part. So, as somebody who is really, down to the bits and bytes level, what is the most mind-blowing CPU architecture you've ever seen in your life? And it's not like you had to work on it, but just like you looked at it and it's like, wow, this is just way out there.
The answer is anything VLIW. Very long instruction words. So that's going to be your Itaniums. That's going to be your TPUs, right? Architecturally wild ideas.
Exactly.
If you want to hire a bunch of compiler engineers, you build a VLIW machine. Because one of the things it does is it's how do I encode the maximum amount of information to fully schedule CPU processes in an opcode? Wild idea. And it kind of breaks one of the fundamental principles, which is people are smart, but they're not getting smarter.
Exactly.
And as we build bigger and bigger machines and more complex machines, if we're trying to drive a single person or a single project to control all of that complexity, good luck.
It just doesn't fit into your head. Yeah,
right?
At all.
It doesn't fit in memory, let alone SRAM.
There you go. That's right.
So, yeah, definitely any VLIW machine. It's nicknamed the ship Titanic for a good reason.
There you go.
It didn't work because we couldn't work on it.
Exactly.
Right, and that's the beauty of the modern CISC machines, the modern RISC machines. But if you look underlying the hardware at like the way we do branch prediction these days, the complexity of branch prediction is ridiculous.
And we actually had that discussion yesterday that, I've been a big proponent of applying AI ideas, to the compiler development. Again, anything that's NP complete in compiler development, like, register allocation, data flow, whatever, I think we can train models to do it better. But you had a great point that we already kind of do AI under the covers, so...
Yeah, so underlying, if you look at the last, say, decade or so of CPUs, those have actually all been running a perceptron for the branch prediction.
Exactly.
Because we could not build a machine that was smart enough, if you will, through just pure heuristics. So looking at the instruction stream and predicting, no, this is probably the way it is. And modern branch predictors, incredible machines that are like 96, 97% accurate. And when you look at like the history of branch predictors, the original ones were just don't ever take the branch because you're probably in a loop, so you're just going to loop the same way over and over again. So it was close enough, but those were 60, 70% accurate. And when you look at modern programs, being able to use the perceptron and other technologies to look through it, well, what's my control flow? And one of the kind of really interesting things that I see my compiler friends talking about is to your point about the NP versus P complete sort of discussion is what's the search space for my optimal solution?
Exactly.
Right? And can I use a model not necessarily to say this is the right instruction, but where should I be focusing my ideas around the search space on selecting the right area of instructions? And it's where the discussions around super optimizers were in the compiler world, and those have been tried, and every time someone tries, it burns out 2 years later. So
it's actually interesting because I have a friend of mine who's been in the Silicon Valley, since Intel for sure, but even before. And I mean early Intel, when Intel was just like a bunch of renegades from and he actually was the first one who started applying some of the early AI ideas to the routing on the silicon. And I think now we're getting close to the point because everybody again, if you look online, everybody's talking about what's scary about AGI is machine building machines. But that's already kind of sort of happening, and I really would love for that to happen more because I think AI-driven design, for anything that applies to silicon, would be really wild. Have you seen anything
there's been product. I'm not gonna comment on how we build stuff internally. There's some stuff I'm not allowed to talk about. But in terms of tool, we're following the tool. So Jim a while ago said he wants all our programmers to be using different AI models so that we can eat our own dog food.
Exactly.
If we say AI is important, then we need to actually be using AI because it is important, right? And where one of the things that's driven there is not only is it a tool for us, but for users, we have to care about what the users are using. And if we can find some of the pain points to their workflows, be it in software or in hardware or anything else, then hey, we can drive that into silicon, we can drive that into the product, and we can also drive that back into open source so that everyone comes out ahead, right? That's the fundamental important.
That's exactly right. All right, well, that's all the time we've got. Thank you so much, and really hope to see you at the next AI Plumbers conference. Everybody gets a t-shirt, like this. We do funny t-shirts, that's why you come to the open source conferences. This one is for you.
Thank you so much.
Absolutely, it was a pleasure.
A pleasure.